Welcome to the today's class, guys, and we will continue with the single row functions that we have been studying since last 3 days. Now today we are going to cover some important of the string functions. The function that we are going to cover first today is substring function. Substring, SUBSTR, that is the abbreviation name of the substring function. This function is actually used for extracting a part of string from the data. So I will explain you the use of the substring function with an example over here. Select substr, that is actually the short name for substring function, substr, A, B, C, D. So this is my data, a string, and I want to extract a part of string from this data, that is the first argument. The three arguments that this function takes can be explained that this first is actually the data. This is the start position from where to extract, and this is the length from the starting position to extract. Means in the output what we can expect is that starting at the third position, that is C, then C, D, E, F will be there in the output. That is actually starting at the position 3, and the length to be extracted is 4 characters long. So these are the three arguments of the substring function, and we can execute this. As you can see that I told you that the output will be C, D, E, F. So that is what exactly this output is. Now there is one more aspect to this. Say for example, five, and I don't give this last argument. Of course this argument second can be anything, but I am just giving it 5 so that it will be another problem. So when I use the starting position as 5 but I don't provide the length, then the actual string extracted from the data, a part of string, that is substring from the data, will be from 5th position to the end. You can see that it starts with E, 1, 2, 3, 4, 5, because E is at the 5th position, and you can see that from E to K. So the last argument defaults to the end of the string, that is the data. So if you don't provide the last argument, then it amounts to extract the length up to the end. Now we can use this function to extract such strings, and also we can use this function to solve such problems as, say, I want to list the rows of employees with their names ending with ER. If such type of problems are there, then also we can solve such problems with substring. Of course there are other methods also. The same problem we have solved with the like operator before. I am talking about the same problem now we can solve with the substring function. So the problem that we are considering over here is list the rows of employees with their names ending in ER. There should be ER at the end of their names. So such type of problems can also be solved apart from like operator with the substring. Of course there can be other problems also, but just for the sake of example I am taking such a problem, and now I will show you the solution to this problem. Select star from EMP where substr, substring ename, because ename will be our data, and I will say -2 equals to ER. So this is how this problem will be solved. Now what is the logic behind this problem is that this substring, and you can see that the position can be given in terms of negative number. When we provide the position in negative, it means that instead of from the left hand side position, we are giving the position from the right hand end. And because we want that the ER should be there at the end, what we are doing is that the string that is containing the ER, we actually take it from the right hand side, the second position, and then we don't give the third position, because you know that if we don't give the third position from the start, whatever we provide, it will take it to the end. And so this expression where substr ename comma -2 equals to ER is valid for searching the rows of employees with the names ending with ER. I will run this. Oh, sorry, this table does not exist. Error is giving. I will say scott.emp, because this table today exists in the Scott schema, and you can also use, if you don't create these tables yourself using the sample table script, then you can also refer to the EMP table that has already been provided by Live SQL platform, but the name will have to be used as scott.emp instead of just EMP. So I will run this, and you will see that these are the two names: Turner, that is ending with ER, Miller, that is also ending with ER. The logic is that instead of providing the position in positive from this end, we are providing the position from this end, which is in the negative, and obviously at the second position from the right hand end it will start, because -2 is there, and it will take it until the end. That is only 2 characters, last 2 characters, because we are not providing the third argument. So such type of problems can also be solved with substring. But of course, I told you that this problem also has got a solution in terms of like operator. Remember that there can be multiple solutions to a single problem in SQL, and there can be different methods utilized by different programmers to solve the same problem. You also need to know how to solve a particular problem in multiple different ways. Of course, it can also be used for extracting a part of string, as I have demonstrated before. Now the next function that we are going to consider here is in-string function. I will clear this screen. In-string function. Again, the in-string function, the name is not complete in-string. It is abbreviated to INSTR. So here we will write a query. Select INSTR, say A, B, C, D, E, F, G, H, C, D, E, I, J, K, L. So that is the data. The first argument is the data, and then CDE. This is the search string, means I want to find the CDE over here in the data. Actually, you know that there are 2 CDEs. One is this that I am highlighting, and then another CDE. Sorry, I will have to put it CDE. And so this is the second occurrence of CDE. So there are 2 occurrences of CDE. One is here, and the another one is here. So there are 2 occurrences, and we say that CDE, and then 1, 1 from 12. Now what is the meaning of this 1 and 1? This 1 basically means that you are starting the search from position 1, that is from A. That is the position 1. You are starting the search. So the third argument indicates the points to the point where the search should start, and then this fourth argument 1 is telling the first occurrence. So this is the fourth argument is the occurrence. You want to search the first occurrence starting with the first position, and obviously this is the first occurrence I am highlighting over here. So it will return the position of this first occurrence. INSTR returns the position of the particular occurrence that you specify over here with the search starting point indicated in the third argument. So when I execute this, you will find that it will return 3 because CDE, this first occurrence CDE actually exists at the third position A, B and then CDE. This is the third position at which this search string is accommodated in the data. Of course, if the CDE would not have existed, then there would have been a 0 coming over here. The 0 indicates that the CDE does not exist in the data. Now, if I want to find out the second occurrence, then it will come out to be this position of this CDE. I will show you the execution of this again, and you will see that it is giving you the position as 9 because this CDE exists at the 9th position. We will count it 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this CDE is at 9th position. So you see that it is returning 9, but it is the second occurrence. Now, if I say third occurrence CDE does not exist. If the search starts with the position 1, then it will return 0. That is what exactly I was telling you, that if such an occurrence of the given cluster of characters in the data does not exist, then it gives in the output 0, indicating that it does not exist in the data. Now, there is more to it. Remember that if I say start the search at say 5 and want to have the position 1. Now, what will be the position returned? Obviously, when I start the search at 5 means I start the search over here where my cursor is, that is at the position where E is in our data. The search will start at this, and the CD's first occurrence. So CD's first occurrence is here where my cursor or the hotspot is, you can see over here. And you might be thinking that this position will be returned from or with reference to this 5th position. Actually, you are not wrong. You are wrong. Remember that the position will always be returned with reference to the left hand end. So what is affected by the start position is the occurrence. Means if we start with the position 1 or 2, then this CD is second occurrence. But if we start with position 5, that is from this E where my cursor is, then this same CD becomes the first occurrence and not the second occurrence. But the position of it is returned with reference to the extreme left end only. I will show you that it will still give you 9 and not with reference to the 5. Remember, this is very important, and these things are asked in the interviews and in the written tests. When you appear for the interview or for the job, they actually give you such type of problem and want you to provide the answer what will be the output of the particular statement. Now, you can see that how this can be used in the real life situation also. Of course, there are a couple of many problems you can solve, but one of the example problems that I am taking for you is that suppose, and already we have actually solved this problem. If I want to find out the rows of employees having double L, again this problem was solved with the like operator. You can go back to those videos. In the early days of our course, we have actually talked about the like operator. And so this is the second way of solving that same problem. I want to find out the names of employees having double L in their name. Then I want to find out the rows of employees having double L. Then what I can do is that select star from EMP. I'm just giving you one of the practical examples how it can be used. Apart from just showing the property of this function. Select star from EMP where instr of ename. Instr of ename. If at all you want that the ename can be in the upper or lower case and you want to provide the search string in the uppercase only, then you can say upper also over here. That is the use of combination of functions ename, so that guaranteed even if the ename is in the lower case, of course in our EMP table the ename is in the upper case, but by chance if it is also in the lower case, still we will be sure that it has been converted into uppercase. So normally such type of function, use of function is also observed in the actual industry. So instr upper of ename, then I will say double L. Now the search will start with 1 and we want to find if the double L is present. So it can be the first occurrence, second occurrence or whatever occurrence. By default the third and fourth argument is already 1 and 1. So we can avoid giving the third and fourth argument because we are not here concerned with whether it is in the first occurrence or in the second occurrence. And so we can just omit the third and the fourth argument and see that is not 0, is not 0, not equals to 0, and again we will have to say scott.emp. And you will see that yes, the same answer that Allen and Miller we are getting. But if we want that the double L should be at the third position, such type of problem was also solved in our with the like operator. Okay, that also we can do using the instr. We can say equals to here 3. I'm just trying to show you the actual use of such functions in the industry. So when we solve this problem, you see that now the Allen has gone, because that in case of Allen the double L exists in the second position, whereas we wanted to have it in the third position, and so we can precisely say that this position should be third because instr returns the position of the given string, given part of the string in the data, and that we wanted to have in the third position. It returns the position. The third and fourth argument is 1 1 by default, and so we are not using it. So I hope you understand the use of the instr function also over here. And this is how you can get the data listed, that is of Miller, because double L in this case is existing at the third position. Now the next string function that we are going to cover, I hope you have understood this use of instr. The next function that we are going to cover is replace. Replace basically is the find and replace like utility. I will clear the screen. Find and replace like utility. So you can use something like this: select, replace A, B, C, D, E, F, G, H, I, again I say C, D, E, J, K, L, that is the data, and C, D, E, this is the part to be replaced if it exists. Say in this text, if anywhere this CD is there, then I want to replace it with say X, Y, Z. Of course, don't think that if we are replacing a cluster of 3 characters, you are supposed to provide only 3 characters over here. It can be anything. It can be 4, 5, okay, and even I will surprise you if you don't give it, what will happen, that also we are going to see. So say to actually dispel your doubts that if a cluster of 3 characters can be replaced with 4 characters, I am using indeed 4 characters, okay, from 12. So all the occurrences of CD will be replaced with WXYZ. You will see that, okay, this in the output. So you see that all the CD occurrences have been XY, WXYZ. You can see over here, it is there for once, then it is for the second time because CD existed for twice in the data, and so the CD occurrences have been replaced by WXYZ. So this is actually, the replace function is actually a find and replace type of utility that you can use in the actual practice. Now, if I don't provide the 4th argument, that is what I was telling you, what will happen if I don't provide the 4th argument. The 4th argument is optional, and if you don't provide, then all the occurrences of CD will be eliminated from the output, meaning that CD is replaced with null. So when null, you know that null is no data, it doesn't exist. Anything which is void or that does not exist, we call it as null. And so you will find that when I use this replace with no 3rd argument, then the occurrences of the 2nd argument in the data will be replaced with a null. I will demonstrate to you, and you will see that, see, all the occurrences of CD have been eliminated from the output. So this is one of the very important use of the replace function also, that if we want to eliminate, because we have seen the trim which cuts at the end, but if we require anything to cut in between, to eliminate something in between, then somewhere in the middle of the string, then we can use the replace function with no 3rd argument, without 3rd argument, and so the string to be replaced will be eliminated from the output, or we can say technically it is replaced with the null. So that is the replaced function. Now the next function we are going to see is the translate function. Translate function is also an important function, and it has got very important properties which can be used for variety of the problems. Now this translate function basically is same like the replace function, but replace was replacement for a string with another string. Here translate basically is replacement on the character per character basis. And so you see that I will explain you, there are a few important properties and at times some complex properties the translate function has, and say I use say HAL. This is the data in which the letters contained in this string, that is data, is required to be replaced. So translate basically is replacing on the basis of character per character, and then I have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Remember that? It is not necessary that you have to use all those alphabets, English alphabets from A to Z. It can be dependent upon the problem. Here I am just considering this to replace any characters in the data, and so I am taking the second argument containing from A to Z. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, Q, R, there is an extra U over there, Q, R, S, T, U, V, W, X, Y, Z, and then this is the second argument. Remember that second argument basically is the set of characters to be replaced in the data. First argument is data, and the second argument is the set of characters to be replaced in the data. Means you want to replace say H, you want to replace say A, you want to replace say L. So character on character basis. How that can be done? With the positional correspondence with the third argument. Here I take B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So you see that I have just taken out the A from there, and the remaining I have shifted to the left hand, and you will see that positional correspondence will be found. So what A will be replaced with? So A corresponds to B in this case. So A will be replaced with B. H corresponds to I positionally. Then H will be replaced with I. And L corresponds to M. You just observe my movement of the cursor. So L will be replaced with M. That is positional correspondence between the second and third argument. The second argument is the set of characters supposed to be replaced in the data, and the third argument is the set of replacement characters which will replace the characters present in the data and in the second argument. Correspondingly, positionally between the second and third argument, I will say from dual, you will see that we will get IBM over there. It will be IBM. As you can see, it is IBM. So that is how actually, you get in the output, because we see that H is replaced with I, A is replaced with B, and L is replaced with M. Now, suppose I have here say ZKL. What will happen? Now you see that as far as K is concerned, so K corresponds to L over here, and L corresponds to M. But what Z corresponds to? Because the Z here does not have any corresponding character in the third argument. And so remember that for any overhang character in the second argument, overhang character in the second argument means there is no corresponding character in the third argument to indicate its replacement. So we call it as overhang character in the second argument. So there is no overhang character for Z in the third argument, third set of characters. So it will be replaced with null. I will execute this. I will execute this, and you see that just as per our hypothesis, there is elimination of Z from the output and there is LM. So we say that K will be replaced with L and the L will be replaced with M, and that is what exactly is happening over here. Now, here basically the next property of translate is that suppose I have in place of Z say 9, numeric 9. You know that 9 doesn't exist in the second argument over here. 9 doesn't exist in the second argument over here, and so because the second argument indicates the set of characters to be replaced, and if 9 is not present in the set of characters to be replaced, that is second argument, it means that 9 is not supposed to be replaced. So it will be taken forward automatically as it is in the output. Let us execute this query, and so you will see that it will be same as 9LM, because K will be replaced with L, L will be replaced with M, and 9 will be carried forward as it is because in the list of characters to be replaced, that is in the second argument, 9 does not exist. So if the data contains any such character which is not part of the list of the second argument or the set of characters to be replaced, then such characters will be carried forward as it is in the output. That is what actually it means. So in this way, we actually today have covered the translate function. Tomorrow we are going to cover a couple of date functions and some of also the problems where these functions can be used, and the practical problems, a couple of I will take, so that you can get the idea about how to use those functions in actual practice in the application development. Of course, there can be several situations where these functions can be used. It is not possible to cover all such situations, but gradually as you practice and get exposure, you will also be able to think in terms of the combination of different functions to use to solve the particular problems at hand without even writing a single line of code. The Oracle built-in functions are extremely powerful, and you can combine them to get the desired results in many cases without writing a single line of code. Believe in Oracle functions to that extent. So thanks for joining.